Hello, this is Michelle here, or you can call me Rebecca. And today I'll be doing a short sharing with regards to prime factorization. Prime factorization is the very first topic in secondary one, normal academic. And for students who are moving on from secondary one NT to secondary two NA, you would realize that you will have missed out in this one important topic that your peers have covered. So I thought that perhaps I would take some time to go through this topic so that you have some kind of a head start. Yeah, so let me just turn on the screen share. Right, now we take a look at prime factorization, what it is. So what's prime factorization? Well, if we were to break down the words prime and factorization, prime refers to prime numbers. Okay, so in secondary one, you would be somehow introduced to the term prime numbers. So what are prime numbers? Prime numbers are numbers that can be broken down into the product of two factors. And it would be the factor of 1 and itself. Okay. So an example of a prime number would be the number 3, because 3 can be broken down into its factors 1 and 3. Another example of a prime number would be that of 13. 13 can be broken down into 1 and 13. On the flip side, let's explore the non-examples of prime numbers. So what are numbers that are not prime? So numbers that are not prime are basically called composite numbers. And this means that they have actually more than 2 factors. So if we look at the number 6, A6 can be broken down into 1 multiplied by 6, and it can be broken down into 2 multiplied by 3. So essentially, the number 6 can be broken down into 1, 2, 3, 4 factors. So it is not prime, it's composite. All right. Now, how about the word factorization? Factorization is a really big word, but if you were to look at the root word, it comes from the word factor. Okay. So in primary 4, you will have learned the word factor. Factor basically refers to a number that is multiplied by another to give a bigger value. So if we were to break down a number into its factors, okay, then we would say, for example, the number 8 being broken down into its factors would be 2 times 2 times 2. Okay, and if each of these factors that it has been broken down into are prime numbers, these are what you call prime factors. Okay. Now, so if we were to break down numbers, okay, into its factors that are prime, let's take for another example, the number 15. 15 is not prime. So if you were to break it down, it would be 3 multiplied by 5. So prime factorization of 15 would be 3 times 5. Another number, say if we were to take 36, that would make 3 times 12. However, you realize that while 3 is a prime number, or rather a prime factor, 12 is not. 12, in fact, can be broken down into 2 times 2 times 3. Each of these are prime factors of 36. So 36 could be broken down into 2 times 2 times 3 times 3. This is actually the prime factorization of 36. If you notice, 2 times 2 has the number 2 being multiplied by itself twice over. It could be written as 2 to the power of 2. 3 times 3 could be written as 3 to the power of 2. So 36 could be rewritten as 2 to the power of 2 times 3 to the power of 2. Now the problem comes when the value itself, instead of 15 and 36, we have a big number, say 1,000. How are we going to find prime factorization of 1,000? Well, we can't be using guess and check all the way. We can't be breaking down numbers endlessly. So there must be another way. And that method would be that of repeated division. So at this point, let me show you what you mean by repeated division and how are we going to go about doing it. So if we look at the bottom right-hand corner, one question taken from the N-levels examination, write 504 as a product of its prime factors. Now, how are we going to break down 504 into its prime factors? Through repeated division, we are able to do so. Okay, so we are going to have this bar, horizontal and vertical, and this basically stands for division. It's like a division bar. I'm going to place 504 over on the first row, and I'm going to divide 504 by the smallest possible prime factor. So what's the smallest possible prime factor of 504? Let's start from the number 2. So 504 divided by 2, using our calculators, we have 252. Now we ask ourselves the same question. Can I divide it with the smallest prime factor? 2, yes, possible. Okay, I divide by 2 again. I have 126. Can I divide by 2 one more time? Yes, I will have 63. Divide by 2 again? No more. So after 2 has been used up as a prime factor, let's move on to the next higher prime factor, which is 3. Can 63 be divided by 3? Yes, that gives us 21. Can we divide it by 3 again? Yes, that gives us 7. Okay, now 3 is out. We move on to the next factor, 5. Cannot. 5 is out because 7, when you divide by 5, we have a remainder. So after 5, the next prime factor would be 7. Yes, 7 can be divided by 7 and we'll be left with 1. At this point, when the row is left with 1, that's where we stop. 504 can be broken down into the numbers, the product of the numbers on the left. Okay, so 504 could be written as 2 times 2 times 2, okay, times 3 times 3 times 7. There you go. Not convinced? Use your calculator and check. It is 504. Okay, now let's condense these numbers. This would make up 2 to the power of 3. This would make up 3 to the power of 2. And 7 is on its own. So this would be the answer when we write 504 as a product of its prime numbers. Let's do one more question together. Write 2,160 as a sum of its prime numbers. Rather, I think we would have to change this to as a product of its prime factors. Okay, so 2,160 equals to, right, on the other hand, I want to draw a column and put down 2,160. So you have guessed it that the first prime factor to divide this by would be 2. So 2160 divided by 2, I would get 1080. Moving on, divide by 2 again. 540. Divide by 2 again. 270. Divide by 2 again. 135. We're done with prime factor of 2. Next, let's consider whether we could divide it by prime factor of 3. Yes, we can. And so 135 divided by 3, we get 45. Divide by 3 again, we end up with 15. Divide by 3 again, we end up with 5. And finally, we move on to prime factor of 5. There you go. We stop at the row that says 1. So 2160 can be written as all right. And how will we group them? The first 4, 2 to the power of 4, because 2 repeats itself 4 times over. 3 to the power of and 5. So this would be the breakdown of 2160 as a product of its prime factors. Well, I hope that today's short session gives you an idea on how we can break down a number into product of its prime factors. The next session, we will cover more grounds. So be sure to tune in. Take care. Goodbye.